The existence of an advanced, large-scale combat aircraft development program, unofficially and colloquially referred to by external analysts as the Chengdu J-36, is supported by multiple, consistent reports from observers who monitor aerospace developments. This program is assessed to represent a significant step in the evolution of Chinese military aviation, focusing on creating a platform with capabilities beyond those of the currently operational Chengdu J-20. The information available is pieced together from a combination of visual observations, analysis of logistical movements, and inferences drawn from the known trajectory of China's aerospace and defense technology. It is critical to state that all information remains unconfirmed by official government or corporate sources, and the program is understood to be in its early stages, meaning all specifications are provisional and subject to change. The fundamental design philosophy of this aircraft, as interpreted by analysts, centers on achieving an unprecedented combination of long-range, heavy weapons payload, and very low observability, commonly known as stealth. This suggests a strategic requirement for a platform capable of operating effectively at vast distances from its home base, in environments where advanced air defense systems and enemy aircraft pose a significant threat. The intended roles are consistently described as a blend of air dominance, where the aircraft would seek to establish control over a wide airspace, and deep strike, where it would be tasked with penetrating defended airspace to destroy high-value targets such as command centers, radar sites, and naval assets. Some analyses further suggest the aircraft could be designed to function as a battle manager or command node, using its powerful sensors and data linking capabilities to coordinate the actions of other, less capable aircraft and missile systems within a networked battlespace. The most frequently cited and distinctive physical characteristic of the aircraft is its propulsion system. Multiple, consistent reports indicate the use of a three-engine configuration. This is a highly unusual design choice for a modern fighter-type aircraft, diverging from the single or twin-engine norms. The rationale for this design is inferred to be a non-negotiable requirement for immense thrust. This thrust would serve several potential purposes. First, it would allow the aircraft to achieve and sustain supercruise, the ability to fly at supersonic speeds without the use of fuel-intensive afterburners, even when carrying a maximum load of internal fuel and a full complement of weapons. Second, it would provide a robust power margin for high-energy maneuvering in a potential combat situation, despite the aircraft's large size. Third, it would ensure performance is not critically degraded by the failure of a single engine. The specific models of these engines are a subject of ongoing analysis, with suggestions ranging from uprated variants of existing Chinese engines like the WS-10, or the more advanced WS-15, to the possibility of a new, previously unknown engine family. The exact configuration of the air intakes and exhaust nozzles, which are critical for both engine performance and stealth, remains a key area of interest for external observers. Regarding the aircraft's physical dimensions, estimates have been formulated through comparative analysis with known aircraft and the infrastructure visible in observation reports. The consensus points to an airframe that is significantly larger than current fifth-generation fighters. Approximate figures often cited include a length of around 22.5 meters and a wingspan of approximately 24 meters. This substantial size is a direct enabler for the reported long-range and heavy payload mission set. The large internal volume is necessary to house the significant fuel load required for a combat radius frequently estimated at around 3,000 kilometers. Furthermore, this volume accommodates the spacious internal weapons bays required to carry a diverse arsenal while maintaining a very low radar signature. The aircraft's weight class is similarly estimated to be heavy, with a maximum takeoff weight potentially exceeding 50 tons. The design of the airframe itself is consistently described as incorporating advanced stealth principles. A key observable feature is the reported lack of a conventional horizontal tailplane, described as a tailless or flying wing type design, or the use of all moving vertical stabilizers. This configuration is a fundamental aspect of reducing its radar cross-section, as it eliminates major right-angled reflective surfaces. The overall shaping of the fuselage, the sweeping of the wings, and the integration of the engine nacelles are all executed with the primary goal of deflecting radar energy away from potential detection sources. The surfaces of the aircraft are likely designed with careful alignment of edges, known as planform alignment, to concentrate radar reflections into a very small number of narrow sectors. The materials used in its construction are assumed to include significant amounts of composite materials and radar-absorbent materials and coatings, which work to dissipate the energy of incoming radar waves. It is crucial to note that there are no verified, specific numerical values for its radar cross-section. Any published numbers are speculative. The assessment is qualitative. The observable design philosophy indicates a primary and thorough emphasis on achieving all aspect, very low observability. The reported internal weapons bay configuration is a direct consequence of the stealth requirement. To remain effectively invisible to radar, weapons cannot be carried on external pylons, which create significant radar reflections. Therefore, the design is said to incorporate 3 internal bays, one large, central bay located in the fuselage, and 2 smaller side bays located on the flanks of the aircraft, likely near the air intakes. The large central bay is logically intended to carry larger payloads, such as long-range air-to-surface standoff missiles, large anti-ship missiles, or multiple air-to-air missiles stacked on a rotary launcher. The 2 side bays are optimally shaped to carry long-range air-to-air missiles in a staggered arrangement, typically one behind the other, to minimize the bay size and drag. The specific armament is not confirmed, but projections are based on the known inventory and development trends of Chinese missile technology. This likely includes very long-range air-to-air missiles, potentially akin to the PL-17, designed to engage high-value targets like tanker and airborne early warning aircraft, advanced within visual range missiles, and precision-guided air-to-surface munitions. The program's developmental status is assessed, based on the timeline of observations, to be in the initial flight test phase. The first reliable observations of a prototype aircraft in flight emerged around the final months of 2024. This early stage involves testing the basic airworthiness, flight controls, and performance envelope of the airframe. It precedes more advanced testing of sensors, weapons integration, and stealth characteristics, which would come in later prototypes. This phased nature of development means that the aircraft's final configuration, its avionics suite, its sensor package, and even its precise performance metrics are not yet fixed and will evolve based on data gathered during the test program. The names J-36 or JH-36 are not official designations but are analytical constructs used by Western observers, think tanks, and journalists to facilitate discussion. The official name, number, and full capabilities of this aircraft will only become clear with time, either through further observational evidence or an eventual official disclosure.